Section 5 talks about linear models and how we can use them in real-world situations, and then how we can draw conclusions based on stuff that has happened in the past. So the first thing we need to talk about is a scatter plot. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. So we first saw that in this course when we did relations, and we used a graph to represent relations. So scatter plot is essentially that graph of the relation of two sets of information. The first example wants you to make a scatter plot. So in this situation, if time is involved, time is an independent variable. So number of hours online is my x-axis. And those numbers range from 0 to 5. So I'm actually going to go every other block as 1. I probably could have chose a little bit more and spread them out maybe every 3 blocks, but really doesn't matter as long as you stay consistent. And that makes the y-axis, the test score. Lowest test score I see is 57 and the highest is 100. So I'm actually going to truncate the y-axis and start right here at 50. And then I'll go by 5s, labeling every other one. Again, probably could have gone a little bit further out, but it doesn't really matter. So then all you have to do is plot the ordered pairs. 0, 100 would be right here. And 0, 94 is about right there. You're guesstimating as best as possible. 198, 188, 1.592, 1.7589, 275, 270, 378, 472, 4.557, that one was pretty low compared to the others, and 5 is 60. Oh, that one's wrong, sorry. That's a scatter plot. It's important to note that scatter plots do not have connections between the points, so don't play connect the dot or anything like that. Just leave them as points and there are no lines in between. So looking back, you talked about correlation in Algebra 1. Scatter plots in the first quadrant usually occur because positive numbers are only in the first quadrant. So a correlation describes the strength of the relationship. On the left, that scatter plot shows you positive correlation, because generally speaking, if you follow the points from left to right, you're going upward. Positive correlations go up, like a positive slope. The graph in the middle shows a negative correlation. From left to right, generally speaking, that graph is going down. So it has a negative correlation. And then the last one is a no correlation because it's very random. In a positive correlation, both values rise together. In a negative correlation, one value goes up as the other one goes down. A trend line or a line of best fit. Typically speaking, they are not synonymous. They don't mean the same thing. A trend line is done by hand, like you find it yourself, and a line of best fit is done by the calculator. It's just a line on a scatter plot. Draw it as close to the points as you can, and you use it to make predictions about the data. Now, even if in this class they ask for a trend line, we're actually going to do them by the calculator every time because it's a lot more reliable. There's really no point in us doing it by hand if the calculator can give us a better answer. So example 2, the table shows median home prices in California. Make a scatter plot and find an equation for a trend line that models the relationship between time and home prices. Use the equation to predict the median home price in 2030. So I am going to make a scatter plot just so we get a little bit more practice with that. Remember that time is always the x-axis, so that's year. And then that makes the y-axis median price in dollars. Now, anytime they give you a year, always make the first year, year 0. And this can be a little tricky. If 1940 is year 0, 1950 would be 10 years later, 1960 would be 20, 1970 would be 30, then 40, 50, and 60. So that means on the x-axis, instead of just calling it years, you have to put years since, and then the first one. In this case, it's 1940. It's years since 1940. All right, so I'm going to do the x-axis first. Those numbers range from 0 to 60. So I'm going to do every other line is worth 10. So 10, and then skip is 20, 30, 40, 50, and 60. Again, probably should have made it every 3. The median home price. Lowest value is 36,000. Highest value looks to be about 250,000. So I'm going to truncate this as well. I'm actually going to go pretty vague on this one. I'm going to start, maybe I won't truncate that. I'm going to actually go by 50,000, and I'll go every other block. So this is 50, that's 100, 150, 200, 250. Which means if I'm going in thousands, I need to write that 50 in thousands. All right, do your best to plot them. So at this point, I actually paused the video and finished the plot. If you haven't finished it already, pause it yourself, finish the plot, and then come back. They do ask for the trend line. And again, trend line is supposed to be done by hand, but for the sake of staying very accurate, we're actually going to do this on the calculator. So I'll show you how to do this on the calculator, the 34s, which are what we have in class. So to do this, you first have to hit data. In the data menu in the left-hand column, that's where you're going to put your x values. Now remember, we changed the x values. We made them 0, 10, 20, and so on. So that's what you're putting in there. So I've entered all of the values 0 through 60. Then I'm going to arrow over to the right, which takes me into the second column. In the second column, I'm going to put the y values. You never, ever, ever change the y values. The only thing you ever change are years, and the y value is not going to be a year. So you're going to put those values in just the way you see them. So 36,700. Enter. So take a second, pause the video if you need to, and get all of the y values in. Once the values are put in, you're going to hit the second button and data again. This screen is asking how many variables you have. Because you have both x and y numbers, you're going to select the second option. You can just hit the number 2, it'll automatically select it because that was 2 variable statistics. And once you hit that, you're going to see the screen that says 2var stats, which is what we chose. They're just asking you where your data is. So right now in my calculator, it says x data is in list 1 and y data is in list 2, which is where I put it. I'm going to go down to calculate and press enter. A whole bunch of information will show up on this screen, all of which is very important for a stats class, but not so much for a line of best fit. So I'm going to keep arrowing down until I see this screen. So take a second and see if you can find this screen. It gives me 3 important values. At this point, little a is important for us. That's 3185.51, round to 2 decimal places. Little b is 39,240.43. And r, which we'll discuss later, is 0.92. So when they want a line of best fit or a trend line, it's actually y equals mx plus b. But this a value is your m, and this is actually your b. So if we plug those into y equals mx plus b, our equation ends up being y equals 3,185.51x, it's mx, plus 39,240.43. This is the best line that they can find for the data. You don't have to do it by hand. It's a really gross process. The last part of the question says, predict the median home price in 2030. So this part can get a little tricky as well. They want to know about 2030, the year 2030. But remember, we talked about the fact that we scaled those years back, and our very first year was 1940. So what you need to do is 2030 minus 1940. That's actually 90. So when x equals 90, I want to know what y is. You're going to put a 90 right there. So take a second and plug that into the calculator. You're going to do 3,185.51 times 90, and then add the 39,240.43. You're going to get a very large number because this is a median home price. The idea here is that in 2030, if home prices continue with the trend that they're on, that home prices in 2030 would be roughly $325,936.33. You use the equation of the trend line to predict what will happen in the future. This information is super helpful for things like population. You know, they have countries in which they're becoming overpopulated, and they use trend lines to say, if we don't do something about it right now, by such and such a year, we're going to be way too populated. Trend lines are very helpful when it comes to stuff like that. So on the last screen when we did this problem, and you can still see it on my calculator, I found an R value. R is the correlation coefficient, and it talks about the strength of a correlation. So what you really want, ideally, is a number close to 1 or -1. So I want to talk about the difference between 1 and -1. That being positive, if it's closer to a +1, it just means that the correlation is positive. Both values are rising together. So in this problem, we found right in here, we found that R was 0.92. That's a positive number, and it is pretty close to 1. If you thought about it as a percent, it's like a 92%. That means that this has a really strong correlation, like 92% strong, kind of. That's kind of how correlation works. And it's positive, which means that those prices and years are rising together. And you can see that on the graph. Generally speaking, if you start left to right, those points are kind of going up. Correlations that are positive go up together. So the closer it is to 1 or -1 is the more accurate your prediction will be. So the higher that number gets, the more accuracy you find. It can also be close to -1, and that's not a bad thing. Often we think that a negative means bad, but that's not the case here. Just closer to -1 only means that your data has a negative correlation. So as one value goes up, the other one goes down. Okay, that happens a lot. Like if you were to plot the amount of time you spend exercising and your weight, it should be the case that if the amount of time you exercise goes up, your weight should go down. That has a negative correlation. That's not a bad thing. It's actually a very good thing. But that's how correlation works. So you want those values to be close to 1 or -1. I usually think like a 0.9 or higher is really good, or 0.9 or -0.9 or lower. So I'll show you a couple examples of those as well. Example 3, the table lists the costs of 2% milk. Use your calculator to find the equation of the line of best fit. Based on your linear model, how much would you expect to pay for a gallon of 2% milk in 2025? So remember, the very first thing that we do is scale back those years. So make the first one 0, no matter what happens. That's 1998. If year 0 is 1998, 2000 is only 2 years later. And then of course 4, 6, 8, and 10. So always remember, you scale back years and absolutely nothing else. No other data gets changed. So you have to return to your calculator to find this information out. If you go into the data menu, it's not cleared. So that might be a problem for you. You're going to have to delete those things out of there. You can press delete a whole bunch of times, or if you don't figure it out, I'll show you how to delete those things a little bit later. So just press a whole bunch of deletes until you're all done. Remember, in list 1 we put the X values, and in list 2 we put the Y values. So pause for a second, get all your values in there, and then we'll continue. The only thing I definitely want to caution you on in this problem is there are two values of y that are 2.93. So make sure that they're both in there. When you're done putting your data in, you should have the same number of items in both columns. One cannot be longer than the other. So once those values are in there, press second and data. Remember, we hit second option for two variable stats, and then go down to calculate. You're going to keep scrolling until you find A, B, and R. So according to my calculator, little a is 0.093, little b is 2.55, 2 decimal places is good, and r is 0.91. Now I want to talk about what those values mean. As an equation, y equals mx plus b, I get y equals 0.093x plus 2.55. That's my equation of a line of best fit. That 0.093, the little a value, which is your slope, that's how much it rises each year. So roughly, the price of milk will rise 9 cents, give or take, each year. The 2.55 is your y-intercept. That's where it started. So it should be the case that whatever number you get as your y-intercept is pretty close to the first value that started in the table. And they can be off a little bit. Remember, this is kind of just an accuracy thing. In fact, this correlation is 0.91. So it isn't as good as it could be. We look for things that are a 0.98, 0.99, but it is certainly a strong positive. The last thing they want to know is how much you would pay in 2025. So in 2025, you're going to do 2025 minus the year you started, which was 1998. When you do that, you end up with 27. So x is 27. You're going to put that right there for the x value and put it into your calculator. So 0.093 times 27, and then add the 2.55 on the end. It should be $5.06. So if the price of milk continues to rise the way that it is, in 2025, you can expect to pay a little over $5 for that milk. Take a second, pause the video, and do the you try it. So I found that the A value is 0.22. That means 22 cents roughly a year movie tickets go up. The starting value was approximately $4.26. The correlation coefficient here, I don't know if you noticed or not, I actually rounded to 3 places. Never, ever, ever round a 0.99 anything up to 1. Because 1 is completely perfect, and you don't really want it to be rounded if you can't guarantee that perfection. So if rounding to 2 decimal places forces you to round up to 1, instead do 3 decimal places, which is what I did here. And then after that, I made the equation. In 2025, x would be 30, so I found $10.86.